When we're having a look at solving exact values for trigonometric angles, we saw that we drew a unit circle and we always drew our triangle to the x-axis. We're going to have an explanation as to why we actually do that when we look at solving trigonometric equations. Here I've just got the graph y equals sine of x fired up, and I just want you to see the wonderful symmetry, the synergy that is in these wave graphs. And we're going to start off with sine. Now, if I go in some angle, or some amount of radians here, some angle there, I'll get to this point here. And what you also notice, if you go from the point pi and you go back the same amount, you should get to the same point there, along here. Get the same value there. Kind of brings us to a nice conclusion that sine of an angle is equal to sine of pi minus the same angle. So that's a trigonometric identity, and that's the first time a sine. Sine of an angle is equal to sine of pi minus the same angle. And so if we have a look at this on the unit circle, if you go some angle out here, right, and we go down to our axis there, theta, the trigonometric identity, pi minus theta, so you start at pi and you go, well, you minus that same theta, that's going to be this value in there. And so that's why. That's why we draw down to the x-axis, right? And so it's kind of nice if you want to look at it from the unit circle. If you want to find the second value for an angle, what you do is you look at the unit circle and we see everything is positive here. And then if it's sine, for example, we go, well, where else is sine positive? You go to the S quadrant and you draw an identical triangle in the unit circle. So those two green triangles, they're supposed to be identical. All right, we'll split out another guy here, is that if you go in some angle here, down to some point, you get some point, you do the same thing here. Go in the same angle, down to some point, and so that gets us a nice sine of pi plus theta is equal to sine of 2 pi minus theta. And so this leads us to the question, if we were given a question, it says find all values for x between 0 and 2 pi for sine of x equals a half. So there's going to be two values where that is the case, right? And so here, sine of something equals a half. I know this has got to do with a 30-60 triangle. It's actually got to do with the value of pi on 6, which is 30 degrees in radians. So I can immediately read off, I can go sine of pi on 6 is equal to a half. And I know that. I can verify this on the unit circle. And here we have a nice unit circle pop up where we have got 30 degrees pops out here. And there's a few ways you can go about this, okay? So we know that this length here would be equal to a half. That's what it implies, right? And so here we can go, well, I'm just going to draw the identical triangle and draw it to the x-axis because that's going to give me that half length there. And so that's going to be 30 degrees. And I can just go, yep, well, that's 30 plus whatever that is, or 180 minus 30, right, which is that trig identity. So then you say, using sine of pi equals sine of pi minus theta. We know what theta is. Theta is equal to pi on 6. And so we can come to the conclusion that this second angle here is 5 pi on 6. So you can say therefore x is equal to pi on 6 and 5 pi on 6. Alright, so I just want to link it in with a few things here. You get solutions here. It's found on the unit circle, which is what we've done here, and it's also on the graph of sine. If I look at this graphically, I'm gonna rub this off for a second. If I go, when does sine of theta equal a half? Around about here. That's the value of a half, and you draw a straight line across, and you get two values, here and here. This happens to be the point, pi on 6, or 30 degrees. This is the point pi, 5 pi on 6, which is the point 150 degrees. Alright, it's very nice. Okay, again, you can do a similar thing. Here is the graph of cos of x. I'm just going to go in some angle just so we can see this. I'm going to go some angle here, theta. I get to this point here. If I go back from 2 pi up to the same point, theta, I'm going to be at the same point. And we can kind of see that if we draw a line across here. So this is going to imply that, and this is our second trig identity, which is, it's a nice one. Cos of theta is equal to cos of 2 pi minus theta. Alright, that one's sweet, and we'll see it on the unit circle. So this is what it implies. If I go out some angle, theta, I know I'm going to get a value here. And specifically with cos, I know that this is my value, the length of whatever that orange line is. Now, what we're saying here is we're saying that yes, I can get the same value for cos if I just take 2 pi and I subtract that amount there. So that's, again, going back into this C quadrant here, everything is positive. You'll end up in the cos only is positive quadrant here when you do that. And you draw your identical triangle back down. There's your identical triangle. There's your theta. You're going to get that same distance there. That same one. So again, you can try it out with some values. We're going to see some examples. Alright, and the same synergy occurs with tan of x. So if I'm just going to go in some angle, some theta amount, I'm going to end up here. If you take the angle 180 degrees or pi, you go in the same amount, theta, you're going to end up at the same point. So tan has got synergy around 180 degrees. Again, this specifically written out is tan of theta equals tan of pi plus theta. Okay, you get two angles that give you the exact same value. This is what it's implying. Two angles give you the same value for y. This guy and this guy, whatever that y value is, that's what it's going to be. And again, we can see this on the unit circle. If you go out some angle here, let's say we've gone out some angle there, the value for tan, okay, that's the value of the gradient, right? That's sine divided by cos. If you, well, you can just extend this out. You actually get the same gradient here, but you have to consider it for this angle again, which is why we always connect it to the x-axis. So hopefully that's crystal clear. We've got cos is equal to -1 on root 2. And I want to know, again, between 0 and 2 pi here. So I know there's going to be two values for two angle values here. And so I know just immediately looking at that has got to do with my pi on 4, or in other words, my 45-degree triangle. And the value for cos is negative. So I'm going to go out into the negative quadrant here, 45 degrees there, and I'm going to get one of my values for cos. Okay, so I'm going to get cos of, and that's going to be 3 pi on 4, 135 degrees, is equal to -1 on root 2. That's one value there. To find my second value, again, you can do this two ways. There's a trig identity, so we can use the fact that cos of theta is equal to cos of 2 pi minus theta. If you want to look at it graphically, you can have a sketch of cos there next to you. You can also use the unit circle because we've got the same synergy in the unit circle, but we consider, okay, cos is negative here, cos is also negative in this t-axis there. I'm going to draw the identical triangle down here, 45 degrees there, and that's going to give me the exact value here. And so we can link this up, right? We go around some angle, we go back some angle. So here, and we know that theta is equal to 3 pi on 4. So therefore, cos of 3 pi on 4 is equal to cos of 2 pi, subtract 3 pi on 4, and that is going to be equal to, if we equate this, No calculator, so I'm just going to say, right, 2 pi, I'm going to turn that to 8 pi on 4 minus 3 pi on 4, so I'm not going to bugger up any fractions here. And I get it equal to 5 pi on 4, which is very nice. Therefore, x is equal to 3 pi on 4 and 5 pi on 4. Set of solutions there are for me, and that makes sense here because we go around 135 degrees there, and here's essentially negative 135 degrees, or going around 180 degrees plus 45 degrees, which gives us 135 degrees here, 225 degrees. There, let's have a look at another one.